Hello, everyone. Welcome to my presentation. I'll be presenting on a water supply management system for Leo Water Company. My name is Henry Owusu. Leo Water Company is a company that supplies potable water to urban communities in Ghana. Leo Water Company currently operates urban water supply systems throughout the city of Kwewu. Leo's water distribution processes entail water collection, water transmission, water treatment, water storage, and water distribution. With that being said, the aim of the project is to create a water metering, billing, payment collection, semi-automating the entire process with advanced analytics, reporting for consumption monitoring, and management decision-making. In a more coherent outline, the distribution management system should be able to manage the readers responsible for the meters and the day or the period they read the meter. It should be able to manage the resources used like the pipes, tanks, and pumps. It should be able to report on the status of the tank. It should be able to manage the pump and pipe details of the distribution. And it should be able to report and manage the bills of the customers. Finally, it should be able to manage and report on the equipment used in the distribution process. Moving on to our conceptual database design. For the water source, one or more pumps can pump from exactly one water source. This is based on the assumption that the water sources are far apart. Moving on to the pumps, a pump or one pump transmits to many pipes. Also, one or more pumps extracts from exactly one water storage. Again, one or more pumps extracts from exactly one water treatment plant. The assumption there is that the pumps come with connecting holes that facilitate the extraction. Moving on to the pipes, one or more pipes transmit to exactly one water storage. Also, one or more pipes transmit to exactly one water treatment plant. Again, one or more pipes transmits to exactly one customer. So that assumption, there was an assumption there too that says that so for the pipes to the customers, there is an assumption that the pipe actually comes with a very huge pipe that comes to connecting nodes to customers. So because there are large firms or non-residential customers as part of our customers, there will be the need for large customers or large companies to require more nodes than the residential or household customers. So moving on to the customers, a customer receives from one or more pipes. That's the relationship with the pipe and then the customers. Now, when we focus on the meter, we can see we are trying to outline that one or more meters is owned by exactly one customer. So that is based on the assumption, or that is based on the rule that the detail that we have more or we have customers that are non-residential and would require multiple meters for their multiple nodes. Also, a bill is paid by exactly one customer. So a bill is directed to the customer. So the bill is charged on the customer's account, exactly that customer's account. Then we have a payment detail is associated with exactly one bill. And a reader generates one or more bill. And then one or more readers can read one or more meters. So that brought about a many-to-many relationship. So in order to correct that, we decomposed the table and then came up with a new table called meter reader. The meter reader is a decomposed table from the reader and then the meter. Now moving on to the logical table derivation, we have the water source table, and that has the source ID as its primary key, and that is the denotion of a primary key being bolded, underlined, and having a hashtag. So every single attribute that has a hashtag and has been bolded and underlined is a primary key. So we move on to the water storage that has tank ID as its primary key, tank name, tank size, tank type as its other attributes. Now we move on to customers, and the customer is a generalized entity with residential and non-residential as its child entities. So the customer ID, that is the primary key in the customer table, will be a foreign key in the residential table, but also the primary key of the residential table. Same goes for the non-residential table. The customer ID in the customer table will be a foreign key and the primary key in the residential table. Same ideology goes with the water treatment plants, the filtration, and then the disinfection process. We move on to the treatment filter that references the treatment plant ID from the filtration section of the water treatment plant. We also go on to the disinfectants that also reference the treatment plant ID from the filtration section. From the disinfection section of the water treatment plant. We have the pumps, the pipes, the meter, the reader, and they all have pump ID, pipe ID, meter number, and reader ID respectively. The meter reader is a decomposed table from the reader and then the meter, and it has the primary keys from the meter and then the reader table being its foreign keys in the table. Now we have the bill and then the payment detail. That's the method that the customers are going to use to pay for the bill. So fast forward to our DDL, that is our data definition language, that's the SQL. We created it in the tables using the SQL, or I created the tables using the SQL. And then for the water source table, we have the source ID as its primary key, and then it's an auto-incremented primary key. So most primary keys in this project are auto-incremented, and then it has it's a tiny, or it has the value, or it takes values that is in the tiny int. So like it takes values within a very small range. And for the water storage, we have the small int, and that takes quite larger values than the small int. And it's also auto-incremented. And there are two types of water storage, that is the pre-treatment and then the post-treatment water storage. So the water quantity and then the tank capacity measure the amount. So for the water quantity, it measures the amount of water in the particular tank at that particular moment. And then the tank capacity measures the amount or total amount of water that that particular tank can actually hold. We move on to the customers and then the residential and then the non-residential tables. Since it's a generalization, specialization relationship, it takes the primary keys as its foreign keys. Same for the water treatment plant. So we have the treatment filters, and then we have the disinfectants, and then the pipes and the pumps. So the pipe and the pumps are more or less like the center of the relationship. So that's why the pipes have more foreign keys than any other table. So we have the meter and then the reader, and then the meter reader, that is the decomposed table. We have the bill, and the bill has invoice suffix. So the invoice suffix is the addition to the customer ID that is going to form the new invoice number on the bill. So the bill is the outline of what the bill is going to look like. And then the payment detail is the amount, or is the way that customers are going to pay. So we created an index here to facilitate query derivation. So we created an index for the tank type, and we also created an index for the households, that is the residential customers, and we also created an index for the companies, that's our non-residential customers. Finally, we created an index for the meter reader. So moving on to our data population. Yes, so we did populate our data with values. Then we queried our data. So our SQL, we queried based on our functionality. So this displays the type details of the residential customers. So we use inner join and then the left join, and then we group them by the pipe ID. So it's going to group the entire results by the pipe ID. We did same for the non-residential, and for the non-residential, we have this, and we realize that only one, for most pipes and pumps, they do not have any relationship with, or for the pipes, it has no relationship with the customer name or the company. So only one pipe in this result had a connection with a particular company. We also displayed the pump details, or we queried to display the pump details, and that we have the pump name and then the pipe it transmits to, the tank it extracts from, and the plant name it also extracts from. We also queried this to return the amount of filters and then disinfectants in a particular water storage plant. So an assumption here was that the storage plant is in two different categories. We have storage plant that does filtration and a storage plant that does disinfection. That's why there is no case of a storage plant having a number of disinfectants and also a number of filters. Also, we check the relationship with the readers and then the meter and then the period they read meter or the readings from. So the red so for here, Brian J read meter number 5004 from the 1st of November 2021 to the 1st November December 2021. Now we move on to the storage status. So this checks the storage capacity that are more than that are less than half full. So it returns the storage or the tanks that are less than half full and tells it tells you how much less it is to reach its total capacity. So here you realize that the tank ID 1003 has only 10 liters of water, and then its capacity is about 1,500,000 liters of water. So the difference is 1,499,990 liters of water. So we finally move on to the query that generates the bill of the customer. So this is done by multiplying the bill rate by the readings on the particular customer's meter. So we also did the concatenation of the customer ID and then the bill invoice or the invoice suffix here to create the invoice number. So here is the invoice number of the customers and then the amounts they are supposed to pay. And because some customers had outstanding amounts, that's amounts they were owing the company, it was added to create a total amount due for the company. Thank you very much for your time.